So, good afternoon, good evening, everyone. So, welcome back again with the. I'm again back with the new problem of the day. So, can I get a confirmation in the chat box whether my voice is audible clearly and loud enough or not? Hi, Rishit. How are you? Okay, so we'll be starting the session. Just let me share the screen. Okay. Okay, thank you, Rishit, for the confirmation. So, today's we'll be discussing the problem of the day for 23rd March, and the name of the question was BST maximum difference. So, let's first of all try to understand the problem statement, and then we'll be discussing what can be the approach, and we'll be solving the entire question with the algorithm. Right? So, how was today's problem of the day? So, were you able to solve the question or not? How many of you were able to solve the question? A quick plus one in the chat box for all of you who were able to solve the question. Okay, so let's read out the problem statement. So you'll be given a binary search tree and then you'll be given a target value. So what you have to do, you must find the maximum difference between the sum of nodes from root to target and from target to child leaf node. So you have to find out the maximum difference. And initially you will be given the root node of the entire binary search tree. That is the question. So first of all, let's try to understand with the help of an example. Okay, so let's write down the given test case and then let's understand it. Okay, so the let's input number one. So in the input number one, you will be given the binary search tree that contains 25, let's say 35, 35, and then here is the 45, 30, 32, and here is the node 20, 22, and 15. So the target value for this question is, you are given the target value as 20. So what you have to do, you have to find the sum of all the nodes from root node to the target node, all the nodes occurring before the target node, and then from there you have to find out all the sum of nodes from target to the leaf node. So first of all, we need to identify where our target node is located in our binary search tree. So target node is present over here. Okay. Thanks for informing. Okay, just a minute. Okay, now it will be clearly visible. Okay, so I was drawing the entire binary search tree input number one, and here is the input number one, and in the input number one, you are given the target node as 20. So you have to find out the sum of all the nodes. So the question wants you to find out the sum of all the nodes from root node to target node. So that would be my sum one. Let me call it as my sum one. So that contains only node 25. from root node to target node, all the nodes before the target node. So the sum one will be equal to 25. And from there, after the target node, all the nodes till the leaf node in the left subtree and in the right subtree. So I'll be getting one of the sum, let's say my sum 2 will be equal to 15 and my sum 3 will be equal to 22. Now what I have to do? Now over here you have to find out that what is the maximum difference. What is the maximum difference? So for this path you will get the sum to be 22 and for this path you will get the sum to be 15. So from someone I'll be subtracting 15 and getting one of the output, possible output, and that would be 25 minus 15 will give me 10. And another possible output is 25 minus 22 and that would give me 3. So what is the maximum difference among 10 and 3? What is the maximum value? It is 10, obviously. Good evening, Joel Mark. Good evening. So the maximum value comes out to be 10 and that is the output for this test case. So basically here you are given a formula that you have to find out the maximum. Let me focus a little bit more on the formula so that you will not make any kind of mistake in the future while solving the test case. So maximum difference from where to where? From root node to target node. From root node to target node. I'm not including the value of my target node inside this sum. So I'll use the round bracket, non-inclusion of the boundary. This sum subtracted and the subtraction will be done by the value starting from target node, sum of the path from target node till the child node, where the child node or leaf node, you can call it as a leaf node to be more precise. Sum of the leaf node. That leaf node can be included, and this is the formula over here. You are not supposed to take the absolute value of this difference, not at all. So you need to focus on this formula very nicely and no modification needs to be done to this formula in order to get the correct output. Is it clear? Yes or no in the chat box? Okay, today I'm going to attend debugging contest. Could you please give me some suggestion? Okay. Good evening, John. Good evening. So okay, so we can have a discussion on that thing at the end of the session. But can I get a confirmation on this formula? Is this formula clear to everyone? Yes or no in the chat box? Okay, thanks for the confirmation. So now I guess if you want me to solve it using one more test case, do you need an explanation using one more test case? Okay, so let me take one more example. Okay, so input number 1 was clear to everyone. So now let's take one more example, and that would be my input number 2. So let's say you are given a binary search tree that looks like this: 2, 1, and 3, and the target node came out to be 2. So for this, what do you need to do? You need to find out the target node. This is the location of my target node. So from root node to target node, what is the sum? Over here, if you observe carefully, the root node comes out to be the target node, right? So the sum of all the elements from root node to target node over here, that is sum 1, is nothing but 0, right? And this is my target node, and the other sum, that is the path from target node to the leaf node, I get one of the sum to be 1 and another sum is 3. So sum 1 minus, I'll get two different values. Sum 1 minus, that is 0 minus 1, that will give me minus 1, and 0 minus 3 will give me minus 3. So I got two different values. And what do you think, what is the maximum of minus 1 and minus 3? It is clearly minus 1. It is clearly minus 1, and this is the output for input number 2. This is the output. And now let's suppose there is a test case in which the target node is not at all present in the entire binary search tree. So what will be the output? The question says that if you are given such a test case, let's say input number 3, I'll take the same binary search tree 2, 1, and 3 that contains the target, let's say, which is not at all present. Target node is equal to 5. So over here, if you observe carefully inside the entire binary search tree, there is no node which is equal to 5, and the output for this test case needs to be printed as -1. So don't confuse yourself. If you see any of the test case in which the output comes out to be -1, that doesn't mean that the target node was not present. Some of the formula, some of the equation, if you put the values, you'll get -1 as the output. But do not think that the target was not at all present, although I can see the target over here. Is it clear in the chat? Is it clear? No, no, we will not get the target node multiple times in the binary search tree. Over here, you are given the binary search tree. Okay. So in the binary search tree, if you observe carefully, there is no repetition. If you consider a binary search tree in which there are duplicate nodes, then that is an entirely different thing of discussion. Here you are given a simple binary search tree. Okay. Okay, Rishit. Okay. So now let's try to solve this question. Till now, is it clear? Was the question explanation clear to everyone? Can I get a quick confirmation in the chat box? Okay. 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 Thank you. So now what do you think? How can I find the output? What can be my algorithm? See, we saw the technique how to solve the test case. So from that, can we derive any of the algorithm? Do you think if I use the same technique to solve the question, it will be acceptable? The technique which we were using, the algorithm, or let's say the process which we were following to get the output for a test case, do you think if we convert that entire thing into an algorithm, it will work properly? What do you think? In the input number one, what was the process of finding the answer? We already saw that was we were finding someone, this is someone, and we were getting the value of sum 2 and other sums as well, and then we were getting two different values from which we'll be getting the maximum one as the output. Do you think converting this entire process into algorithm will give me the actual uh, solution of this question? Yes, you will be getting the entire solution by simply following this process. So the process was like this. Let me take one more example to make it more clear. So we'll get the entire algorithm. Okay, so I'm taking the same binary search tree, but what is the difference? I'll be changing my target node. Okay, so let me change my target node, and over here, let's take the target node as 35 instead. Yes, Rishit, it will work. So I'm taking the target node as 35. So the first process is, what is the first process? If I take a look at the formula, I need the sum of all the nodes. If I take a look at the formula, I can see over here, I need the sum of all the elements or nodes from root to target, not including the target. So I need to get this sum, and I'll be calling it as, let's say, sum 1. So over here, you are given the target value as an integer value. You are not given the reference of the node of binary search tree. You are given an integer value. So first process is to find the actual node present inside your binary search tree. So simultaneously, I'll be noting down the steps of the algorithm. So pay proper attention over here. Find the target node. Half of our work will be completed if we get the target node. Okay. So first of all, we need to get the reference. So I'll be using a reference variable, or what do you say, a reference variable, to store the reference of my target node. So I'll be searching entire binary search tree. So over here, you are given a binary search tree. So what is the property of a binary search tree? Anyone in the chat box? Anyone from the audience? What is the property of binary search tree? A pretty standard thing that all the nodes in the left subtree are going to be lesser than your root node. That is, left subtree nodes are going to be lesser than your root node, and the root node's value is going to be lesser than all the nodes inside your right subtree. So this is the property of my binary search tree, right? So I can easily find the target node by simply iterating over this binary search tree. And let's say I got the target node, and I'll be storing the reference in some reference variable, and I'll be calling it as my temp. Yes, Jodh. Yes, exactly. I'll be storing it inside my temporary variable. So while iterating, what I'll be doing, I'll be simultaneously storing the sum value. I'll be simultaneously finding the sum of all the nodes from this root node to target node, but not including the value of my target node. So that process will look like this. Let's iterate and find the target node. So currently I'll be iterating and I'll be finding that this is my current node 25. So what do you think? 25 value is lesser than 35. So target value is greater. So I need to move in the right subtree. I need to move in the right subtree, and simultaneously I'll be having my sum variable sum1, and that will be initialized as 0. So I'll be moving in this direction, and I'll be adding the value of 25 to sum1, and the sum1 will be 25. And over here on reaching this node, I can see this is my value equivalent to target node, and I'll be calling it as my temporary node, and I'll be storing its reference. So I got the value of my sum1. If you do not know the algorithm to find or search an element inside the binary search tree, I would highly recommend go through that algorithm, right? So I got the sum1 as 25. So now here I have the reference of my temporary node. So now what else I need to find? I need to find this sum, that is sum of all the nodes from target to leaf node, but not including the value of my target node. So what I will be doing, I will be simply iterating over all the elements of left subtree of this target node and all the elements of right subtree of my target node. And in which manner I'll be calculating the sum? I will be following the path that leads to a leaf node. I'll be following the path that leads to a leaf node. Till now, was it clear or not? Can I get a confirmation in the chat box? Okay, I'll come to that point as well. I already explained that test case. If the target node is the root node itself, then the sum value will be whatever value was initialized. Sum was initialized to 0. It will remain as it is, right? Because you are not adding anything, and at the root point itself you got the target node. So that means nothing was added to your sum variable, and your sum1 variable will be equal to 0 in that case. Was it clear, Naikaj? Okay, so now I will be following this path. So I need to simply iterate over all the elements. Let's iterate. So let's say I'm making a function call on the right subtree, or let's say for now I'm making a function call in the left subtree. So I'll be storing that value. Let's say I will be having one more variable sum2, and one extra function call will be made on the left child of my target node. So currently I'll be at this point, 30 is my left child, and sum2 was initialized as 0. Is 30 a leaf node or not? 30 is a leaf node or not? Yes or no? No, 30 is not obviously a leaf node because it has got a right child. So what I'll be doing, I'll be adding the value of this node which I encountered to my sum2 variable, and that would be 30. So sum2 is containing 30. Now, can I make a call in the left hand side of this 30? No. So can I make a call in the right hand side? Yes, I can make a call. So I'll be making a call on the right hand side of 30, and currently I'm standing at 32. So do you think this 32 is a leaf node? Yes, obviously 32 is a leaf node, right? Because it doesn't have any child nodes. So this value needs to be added to your sum two variables. So I'll be adding 32 over here. So 32 plus 30, that would be 62. So your sum two variable, one of the path that leads to a leaf node gave me the sum equal to 62. Now I cannot go further from here. So what I'll be doing, whenever I reach a leaf node, I'll be calculating the difference of sum 1 and sum 2. So what is the difference? 25 minus 62. What is this value? 25 minus 62. What does it give me? 25 minus 62. It is 37. To be precise, minus 37. Right? So I got one of the value, minus 37. One of the difference. So I need the final answer. So I'll be having one more variable that is called my answer variable. And it will be initialized as minus infinity, because anything will obviously be greater than minus infinity, right? So whenever I find a difference, sum 1 minus sum 2, I'll be comparing with my answer variable. Whatever is the greater value, I'll be assigning it to answer variable. So minus 37 will be currently present over here. So minus 37. Now I have explored everything on the left subtree. So now I'll be making a function call on the right hand side, on the right subtree, on the right subtree. And sum2 variable will be again initialized to 0 because I have shifted to entirely new tree. It's 25 minus 62, that's minus 37. Okay, so sum2, and currently making a function call on the entire right subtree. Currently I'm standing at 45. So do you see it is a leaf node or not? Yes, it is a leaf node. So first of all, add the value of leaf node to your sum2 variable. So that would be 45. And then you can calculate sum 1 minus sum 2. So what is sum 1? Sum 1 is nothing but 25 minus 45. What do you get? Minus 20. So compare it with your answer variable. What is the maximum of minus 20 and minus 37? It is obviously minus 20, right? And now I have explored everything, every path from target to leaf node for the right subtree as well as for the left subtree. So whatever is the value of my answer variable, I can see it is minus 20. That is going to be the output for this test case. Was it clear? Everything revolves around finding the sum and simply traversing the subtrees or searching for the target node. Was it clear? Yes or no in the chat box. Was this part clear or not? Can I get a quick confirmation so that I can proceed further and write down the algorithm? Okay, thank you, Rishit, for confirmation. So from this, I can frame out the entire algorithm. The important points of the algorithm can be written from this process. So the first point was, over here, I'm noting down the algorithm. So the first point was to actually find or locate the target node. So I'll be calling it as find the target node. Right? So the main purpose of writing the algorithm is that many of you might be coding in different languages, right? So if I will be coding in a particular language, directly the coding part will not be understandable by everyone, right? So over here, algorithm. So can I know how many of you code in Java? How many of you code in C++? Can you write down in the chat box? So the first point was find the target node. I got the target node. Now I want to find the sum1 variable. Sum1 contains the sum of all the nodes from root to target. It will be better if I do not use this sigma, right? So I'll be using, it is nothing but sum of all the values from root node to target node. Over here, target node's value has not been included in this sum. And the next point was the third point. Okay, so I can see many of you code in C++. That's a really good thing. So the next point was to get the value of sum2 variable. But before finding the sum2 variable, we need answer variable as well, right? So I'll be getting the answer variable, and answer variable will be initialized as minus infinity, and this will be a global variable, so that whenever I reach a leaf node, what I can do, I can simply access that global variable and compare the value and assign the greater one. So now here comes the fourth point, that is find the sum2 value. Okay, Joel, you code in Java? Yes, that's really great. Java is a very good programming language, but I think like many of you find it very difficult. Do you find Java difficult? If those of you are coding in C++, what do you think? Do you think that Java is like very difficult to learn or anything? Because I have seen many of the students that they start learning coding with Java, and they find it to be very difficult, while that is not the case with C++. They find it pretty easy to understand. I don't know why. Okay, I myself started coding with Java, and I find it real interesting. So I need the value of sum2 variable, right? So sum2 variable is nothing but what? It is sum of nodes, and I'll not be including the value of my target node to a leaf node. Leaf node will be included. So this value, I'll be getting many different value. Let me write down it as, let's say, a. There would be one more value, because there are different paths from the target node to a leaf node, right? There are many different paths available, and this value will be called as b, and so on. And at each and every point, whenever I find a value a, b, or c, what I'll be doing, I'll be doing sum1 minus sum2 minus sum2, and this will be giving the actual required calculation according to the formula. Yes, but before C++ as well, you should start coding in C language, right? So you should prefer C language first, and then. But that's not a point of like discussion. You can start with any language, but you should know two different kinds of programming language. You can learn either procedural programming language, and one of the language should be object-oriented programming language. Okay. So sum1 minus sum2 needs to be calculated, and whenever you find this value, sum1 minus sum2, compare it with your answer variable. So answer variable will always be initialized the value whichever is maximum. And at the end, the last point is to simply print the last point is to simply print the value of your answer variable. This step needs to be done at each and every sum2 value. And last point is to return, or let's say print the answer variable. This is the entire algorithm. Do you have any kind of doubt in this algorithm? Is this algorithm clear to everyone? A quick confirmation in the chat box so that we can code. The code is a little bit lengthier, so can I get a confirmation for this? Yes or no in the chat box? Okay, thank you for the confirmation. So I'll be simply converting this algorithm into coding. That is simply applying the respective formulas or respective algorithm for binary search tree. Over here, you need to focus that you are given a binary search tree. Okay, so do not confuse yourself that you have considered it as a simple binary tree and you do not take the advantage of the property of BST. Okay? So in order to find the node, let's first of all code down the point number one. I'll be going point wise and will be having no difficulty in understanding the code. So currently I'll be coding in Java, but the same thing can be implemented in C++ as well. Okay. So let's first of all code the point number one. So the point number one was find the target node. Okay, actually I need to find the reference of it. So what I'll be doing, I'll be simply iterating over the binary search tree. And I'll be starting the iteration from the root node. And I'll be calling the reference variable as my temporary variable. If you want to search any of the element inside the binary search tree, what you can do, you can simply call a recursion, or you can use a simple for iterative approach as well. So over here I'll be using an iterative approach. So while the temporary node is not equal to null, that means you will keep on searching until you reach end of the entire BST. At that time you will be stopping. So over here we'll be comparing the value of temporary node with the target value. You need to find. So the algorithm is that if you find the temporary node's value to be equal to target, at that point you can say I got the node and I'll break the iteration. If the target node is lesser than your temporary node, then what you need to do? You need to go and look in the left subtree. So I'll be going in the left subtree. And over here, simultaneously, I'll be getting the value of some one variable. I'll be getting the value of some one variable because as I'm reaching the target node, I'll be in my path, I'll be encountering all the nodes present in this path. And the sum of all this node is nothing but sum one. So why don't you utilize this step to calculate sum one as well? So simply I'll add one more thing, that whenever I encounter a node, I'll add the value to my sum one variable. Okay. So for that I need to initialize the sum one variable as well, is equal to, initially let's say it is equal to 0. Else if this is not the inequality between target and temporary node, then what you need to do, you simply need to add the sum one, whatever is the temporary node, add it to your sum and move in the right hand direction, that is explore the right subtree. I'll be exploring the right subtree and simultaneously I'll be calculating the sum one variable as well. So over here you are given in the question that if the target node is not present, then simply return -1. So if I don't find the target node, then what will be the condition? The reference of target node is present inside the temporary variable. So if I don't find the target node, then your temporary variable will be equal to null. If the temporary variable or reference variable is null, then return -1 from that part itself. Is this part clear or not? Is this part clear or not? So over here we did two steps. Is this part clear or not? I got the sum one's value and I got the target node as well. Half of our task is complete over here. A quick confirmation, so we'll be coding the other half of this algorithm as well. Okay, thank you, Rishit. So now the second part is, let's get back to our algorithm. I need to get an answer variable. Okay, answer variable. Let's calculate. Let's declare the answer variable. So as I mentioned, it should be a global variable. I'll be calling it as static because over here every method is static. So if you want to access any variable outside the method, then it needs to be static. That's language dependent. You can ignore if you don't code in Java. So static variable, and or you can simply take it as a global variable. You can understand this point. This is a global variable. So answer is currently equal to 0. I have initialized. Let me initialize inside this part, inside our method. So I got the answer variable. Now what is the another step? I need to find some two variable. I need to find some two variable. So what I need to do? I need to iterate over the subtree that contains target node as the root node. So for that, a simple iteration is required. So I'll be writing down a function that will be iterating over the subtree having target as the root node. Okay, so first of all, let me write down that function, entire function. So that function will be initially, it will be static in nature and it will be returning nothing. And I'll be calling it simply as a function. And I'll be, let's say, there would be an argument that would be the current node where I'm present, and there would be one more value that would be my sum2 variable. So that sum2 contains all the nodes, sum from target to the leaf node. Okay. So now this is simple iteration. So what I will be doing, if I reach a point when the current node is equal to null, at that point I'll be simply returning from that point. I'll be doing nothing. But if I reach a leaf node, then what I'll be doing? First of all, I need to check whether the current node is a leaf node or not. That means its left and right subtree are going to be equal to null, left and right. If the left child and the right child, both of them are null, then that means a leaf node has been encountered. So at that point, you need to first of all add the value of leaf node into your sum2 variable. Over here, while solving, we did that thing, right? Sum2 needs to be added. Leaf node. So current dot data, that means leaf node will be added over here. And I will be comparing the value of sum1 minus sum2 with the answer variable. Whatever is the maximum value will be initialized. The answer and maximum of sum1 minus sum2. And from there you can return because you have reached a leaf node. So now if this is not the case, make a call to the left child and the right child, or you can say left subtree or the right subtree. Current dot left, and while moving to the left subtree, you need to add the value of your current node to your sum2 variable. So sum2 variable and the current node will be added, and now I need to make one more call to the right subtree as well. So one more call will be made. The call has been made. So this function will give me the different values of sum2, and it will be subtracting sum1 and sum2, and it will be comparing with the answer variable. Was this function clear to you? This is simple iteration, and whenever I see a leaf node, I am calculating sum1 minus sum2. We have to also make sum1 static, right? Yes, you can make it as a static variable. If you don't want that thing, I can pass it as an argument as well. Okay. So over here, let's make it static instead. And this will be static. So it will be accessible from this function as well. Rest of the part, was it clear or not? A quick confirmation. So I'll be completing the code, entire code. A quick confirmation, please. Okay, so we'll be moving further. And now let's see what is the next step of our algorithm. So we wrote down the entire function to calculate sum2. Now we did this process as well. And the last point is to return the answer. But before moving to this point, we need to make sure, we need to add one thing. We'll be looking at some corner test cases as well. First of all, let's make a function call to the left subtree of target node and right subtree of the target node. So what I'll be doing, if my temporary node contains left subtree, that means if the left child is present, then and only then I'll be making a function call on the left subtree of temporary node. And the sum2 argument will be 0 because nothing has been added yet. And the target node is not going to be the part of sum2 or sum1. And let's make a call in the right subtree. If this is not null, then make a function call to the right subtree. Over here as well, the sum2 is going to be 0. And at the end, you can return the answer variable. Okay, thank you for the confirmation. So now let me give you one of the corner test case where this algorithm will fail if you don't add that condition, and answer should be initialized as infinite, not zero. So let's see an algorithm. Let's see the algorithm. Let's take the tree 2, 1 and 3, and let's say the target was the leaf node. If the target was a leaf node, and our answer variable will be equal to minus infinite, and our sum variable, what will be the sum variable? First of all, I'll be looking for the target node. This is my target node, so obviously sum 1 will be containing only node number 2 value. Okay, so that would be it will be present. And now over here, if I return the answer value, it will return minus infinite according to our algorithm, according to our code. See, after getting the temporary node, I'll be getting the target node from this logic, and this condition will fail because target node is actually present. So temp will not be equal to null, and answer will be initialized to minus infinite, and function call if required will be made, and then over here you are returning answer value. But answer will not be updated because the target node is a leaf node itself. Are you getting my point? Answer value will not be updated because the target node is a leaf node, because a function call will be not made on the left child or the right child of a leaf node. Hence answer will be returned, and answer will be returned as minus infinite. So over here, in order to handle this thing, what you need to check, if the target node is a leaf node or not. So check, let's say if temp dot left is not equal to null, let's say if it is equal to null, and temp dot right, both of them are null, then that means it is a leaf node. So in that case, you have simply have to return the value of your sum one variable over here. Observe over here. Over here, sum one minus sum 2. Sum 2 is not present, but sum 1 is equal to 2. So 2 minus 1, 2 minus 0 will be 2. 2 needs to be returned, not minus infinite. So 2 will be returned from this point. Was it clear? Was this part a corner test case clear to you? Yes or no in the chat box? A quick confirmation in the chat box. Was this part clear? This corner test case, was it clear? You need to understand why I need to add this condition over here. Okay. So now let's compile and run. Let's see. Let's hope for no compilation error. Let's see. Okay, so over here we didn't get any compilation error. Let's try to submit it and see. Okay, and the problem was successfully submitted. The question was pretty easy. We simply need to follow the process of solving the test cases and convert that thing into simple coding implementation and algorithm part. Was the entire logic clear to everyone? The implementation part as well. Was this part clear? Okay. So this was the entire algorithm. And now when we can take a look at the time complexity as well. So what do you think, what will be the time complexity of this approach? Anyone from the audience? So what do you think, how many nodes are you will you be iterating in worst case? So in the worst case, first of all, you need to figure out that whenever you see a question that it contains a binary tree or binary search tree, always think about skewed binary tree. Always think about skewed binary tree in order to figure out the time complexity in case whenever you see the question based on binary trees. Okay, so if you are getting a skewed binary tree, let's say that skewed binary tree was like this: 5, 7 and 9. Okay, so over here you will be given a target value. Okay, so I'm over here, I have given an example. Let me convert it to BST, so that would be more relevant. 9, 8, 7, 6. Okay, and let's say you are given a target node 8. So in order to calculate sum 1, you will be iterating over this many number of nodes and you will be reaching this target node. And now to calculate sum 2, you will be iterating over this many nodes. So how many nodes are present? Let's say n number of nodes are present, and how many nodes did you encounter? How many nodes did you traverse? Obviously you traversed total number of nodes inside your BST. So the time complexity of this approach comes out to be order of n. Thank you, Joel. I really appreciate, like, this was like informative and you are getting the point which I'm trying to explain. All for finding target node. All for finding target node is not present. All for Naikaj, I cannot understand. Can you please rephrase this statement? Yeah, my thoughts process are match with you. Okay, I really, it's a pretty good thing if you think in the same manner, because every time you write an algorithm, there is a corner test case. Okay, so you need to figure that corner test case because if you don't figure out that corner test case while you submit the code, you'll get lots of like error in the submission part. And thankfully over here, you get to know that which test case is failing. While whenever you are giving some online interviews or online assessment, you will not be getting the test case which will be failing. Okay, so thinking about the corner test case while writing the algorithm is very very important, because it saves lots of time. If I remove this part, no, let me show you example. If I remove this part and if I submit it, your code will fail. See, and over here if you see this kind of negative number or very large number in the output, and in that intense situation when you are giving interview, this really this gives a feeling of very bad frustration, and you will be very much like confused, and your like energy will be decreased by this. Okay, so this corner test case needs to be handled, and you need to write the algorithm with this condition as well. So, do you have any kind of doubt in this? Do you have any kind of doubt? I'll be waiting for a few minutes, and let me share the code of this as well. Okay. The same thing can be implemented in C++ as well, because only there would be a difference of syntax. Okay, I've shared the link of the code in the chat box as well, and the description part will also contain the entire solution. Okay, so that was it for today's problem of the day. I hope you really enjoyed the session and it was uh, interesting and informative. So we'll be ending the session here only. I'll be waiting for like few minutes. If you have any kind of doubt, I'll be more than happy to answer your doubts. Yes, yes, Chul, I can. Yes, please share what are your thoughts, anything on what topic you need suggestions. For C debugging contest. Okay, so what is that contest all about? Anything extra? Like, I'm not aware about that contest you are. Okay, okay, Naikaj. Good night. Bye bye. If you want to connect with me, you can connect over LinkedIn as well. You can simply write down my name, Dalsaniya. It's visible on the screen as well. So, Joel, you can connect me over LinkedIn as well. So, I can end the session here only. We can have a discussion over there as well. Okay. Okay, so we'll be ending the session here only, and it was great interacting with you all, and the audience was also very interactive, and it's really the mentor also feels good if you interact with him and answer all the questions, right? So we'll be ending this session here only, and those of you want to connect with me, you can connect over LinkedIn. It's offline contest where students debug errors in the C code. Okay, so what suggestion do you need? So it will be better if you connect over LinkedIn. So let's not make this session lengthier and add all the extra talks over here. Okay. So connect me over LinkedIn if required. So we'll be ending this session here only. Thank you everyone. Thank you. Good night and best of luck for the next problem of the day.